our last lecture we discussed about binding energy, right? So in our today's class we are going to discuss about geostationary satellites, right? Geostationary satellites. So here it is an artificial satellite, right? These are artificial satellites. These are artificial satellites which appears stationary to an observer. Stationary to an observer. Stationary to an observer on Earth's surface. On Earth's surface. On Earth's surface. So here, these are also what? Artificial satellite. Artificial satellites. Here, these are all artificial satellites which appear stationary. So, which appear stationary means what? Here, stationary means what? Rest. So, how they are appearing means they are at rest. So, how that is at what time means which at when means to an observer. So, to an observer on the surface of Earth. To us, when we are going to observe on the surface of the Earth, those stationary, geostationary satellites are what appears stationary. See here, geo means what? Earth. Stationary means what? Rest. And the Earth surface of Earth, when we are going to see those geo satellites, so they are appearing stationary. They are appearing what? Stationary. Those type of satellites are called as what? Geostationary satellites. Right? Here, this example is that is INSAT. Right? So INSAT, it is what? INSAT. Indian National Satellite. Indian National Satellite. Right? Indian National Satellite. Indian National Satellite. Another one is that is Apple was the first geostationary satellite. Apple was the first geostationary satellite, right? So here, area, passenger, payload experiment. So this is the first geostationary satellite. This is the first geostationary satellite. That is Apple. That is what? Apple. Another one example is that is INSAT, Indian National Satellite. So these are known as what? On the Earth surface, above on the Earth surface, when we are going to observe those satellites appears to our eyes, those are stationary. Those types of satellites are called as what? Geostationary satellites. But after this one, polar satellites. satellites. Right? Here, these are the satellites. These are the satellites. These are the satellites. Revolves in polar orbit. Revolves in polar orbit. These are the low altitude. These are the low altitude. These are the low altitude satellites. These are the low altitude satellites. See, here the satellites revolve in polar orbit. Revolve in polar orbit. So polar orbit ಒಳಗೆ ಯಾವಾಗಲೂ ಏನು ಮಾಡ್ತವೆ ತಿರುಗ್ತಾವೆ, right? So these are the low altitude satellites. So you ಹೆಂಗ ಬಹಳ ಹೈಟ್ ಕಡಿಮೆ ಇರ್ತೈತಿ. ಭೂಮಿ ಏನು ನಮ್ದು ellipse ಇರ್ತೈತಲ್ಲ, right? So this is considered as a foci, right? Whatever the height, so this is polar orbit. So this is polar orbit. See, consider here. This is very near. This is very near. So these are revolving around like this. These are revolving around like this. So that's why these are the what? Low altitude, low height. Altitude means height. Satellites, right? These are located at the height above 500 kilometer to 800 kilometer. 500 kilometer to 800 kilometer. So ಈ 500 kilometer ಮ್ಯಾಗ 8 kilometer 100 ಒಳಗೆ ಏನಾಗ್ತಾವ ಲೋಕೇಟೆಡ್. ಅದು 500 kilometer ಮ್ಯಾಗ ಇದಕ್ಕೆ ಹೆಚ್ಚಿಗೆ ಇರೋದಿಲ್ಲ. ಲೋ ಆಲ್ಟಿಟ್ಯೂಡ್, ರೈಟ್? ಗೊತ್ತಿರಲಿಲ್ಲ. ವೆರಿ ಗುಡ್. After this one, right? So Indian remote sensing satellite. Next one, Indian remote sensing satellite. Indian remote sensing satellite, right? So these are the polar satellites. These are the polar satellites. These are the polar satellites, right? Which collects information which collects information from a distance. Right? So Indian remote sensing satellites, right? So these are the polar satellites. So these are also coming under polar satellites only. So these are collecting the information from a long distance. So ಬಹಳ ದೂರದಿಂದ ಇರುವಂತಹ ಡಿಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿ ಇರುವಂತಹ ಇನ್ಫಾರ್ಮೇಷನ್ ನ ಏನ್ ಮಾಡ್ತೈತಿ, ಇದು ಕಲೆಕ್ಟ್ ಮಾಡ್ತೈತಿ. ಅವು ಎಂತ ಸೆಟಲೈಟ್ ಅಂತ ಕರಿತೀವಿ ಅಂತ IRS ಸೆಟಲೈಟ್. ಸೊ ಮೀನ್ಸ್ ಇಂಡಿಯನ್ ರಿಮೋಟ್ ಸೆಟಲೈಟ್. ಇಂಡಿಯನ್ ರಿಮೋಟ್ ಸೆಟಲೈಟ್ ಗೊತ್ತಿರುತ್ತೆ, ರೈಟ್? So that one, GPS GPS ಅಂತ ಹೇಳ್ತೀವಿ. ಏನ್ GPS? ಗ್ಲೋಬಲ್ ಪೊಸಿಷನಿಂಗ್ ಸಿಸ್ಟಮ್, GPS, right? So here global positioning system, global positioning system. So now GPS ಈಗ ಕುಂದಿರ್ತೀವಿ. ಯಾವುದೇ GPS ಇತ್ತಂದ್ರೂ ನಾವು ಎಲ್ಲಿ ಅದೀವಂತ ನಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ, ರೈಟ್? ಈಗ ಸಪೋಸ್ if a vehicle is there, that is car or bike, if that bike is having GPS connection, if that bike is or the vehicle is having GPS connection, now we have to identify where the car is, where the vehicle is. So that is global positioning system. Global positioning system. Global positioning system, GPS ಅಂತ ಹೇಳ್ತೀವಿ, right? After that one, weightlessness, right? Weightlessness. Here it is the condition of zero weight. It is the condition of what? Zero weight is called what? Weightlessness. Or it is the state in which it is the state in which the relation on the body is upside. So weightlessness, hang ಮ್ಯಾಗ ಹೋಗ್ಕೊಂತ ಹೋಗ್ತೀವಿ ಹಂಗ ನಮ್ಮ ವೇಟ್ ನಮ್ಮ ಕಡೆ ಇದ್ದಂಗಿರೋದು ಏನು ಇಲ್ಲ ಅಂತಲೇ ಇರುತ್ತೆ ಅಂತ ಅನಿಸ್ತದೆ, ರೈಟ್ ರೀ? ಅಂದ್ರೆ ಗ್ರಾವಿಟೇಷನ್ ಪವರ್ ಬಿಟ್ ಆದ್ಮೇಲೆ when we pass the field of gravitation, then we are feeling what? There is a weightlessness, right? So this is the concept of weightlessness. ಗೊತ್ತಿರಬೇಕು. So here what this gravitation chapter is completed here. This gravitation chapter is completed here, and here another one thing, that is here the problems of this chapter we are going to take now, right? Calculate the force exerted by the earth. Calculate the force exerted by the earth on the moon. Right? Mass of the earth mass of the earth 6 into 10 raised to 24 kg. 6 into 10 raised to 24 kg, and the mass of moon is, and the mass of moon is, 7.4 into 10 raised to 22 kg. 7 raised to 22 kg. Right. R is how much given? 3.84 into 10 raised to 5 kg. 3.84 into 10 raised to 5 kilometer. Right. G is how much given means, that is 6.7 into 10 raised to minus 11. 6.7 into 10 raised to minus 11 Newton meter square per kg square. Newton meter square per kg square. Right. So here, what is the force between these two bodies? One is mass of the earth given, another one is what? Mass of the moon given. So there is what? The distance between those two also given, right? So then what is the, right? So now we are going to consider. So here what happens? First I am going to take solution here. So mass of moon, right? So here how much? Mass of moon, how much it is given? 7.4 into 10 raised to 22 kg, right? So then mass of earth, how much it is? 6 into 10 raised to 24 kg, right? So then radius or the distance between those two planets is given. R is equal to how much? That is 3.84 into 10 raised to 5 kilometer. Into 10 raised to 5 kilometer. So then G is also given. How much it is? 6.7 into 10 raised to minus 11 watt Newton meter square per kg square. Newton meter square per kg square. So then here what is the force? So then force is here, we know the formula, G m1 m2 divided by r square. G m1 m2 divided by r square. ಯಾವದರ ಒಂದು m1 ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ, ಯಾವದರ ಒಂದು m2 ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ. Right. So then what is our G? The value is given 6.7 into 10 raised to minus 11. So what is m1 here? Whatever, whichever you take. 6 into 10 raised to 24 into 7.4 into 10 raised to 22 divided by r square is there. So 10 raised to 5, 10 raised to 5, how much it becomes? 10 raised to 10. Now I am going to write doublet of this one. 3.84 into 3.84, 10 raised to 10. 10 raised to 10. Right. So now it becomes, see, 6 point, can I write the calculate here? 297.48. 297.48 into 10 raised to how much? It is 25. 25. Right. Here 25 not here. इधर हाथ होइते ತಿಳ್ಕೊಳ್ಳಿ, ರೈಟ್ ರೈಟ್, ಇದು ಹಾತ್ ಹೋಯಿತು ಅಂದ್ರೆ ಇದ್ರ ಹಾತ್ ಕಳಿತೇನೆ, ಕರೆಕ್ಟ್? ಇದ್ರ ಹಾತ್ ಕಳಿತಂದ್ರೆ 22 ಉಳಿತು, ರೈಟ್ ರೈಟ್. 22 ಎಷ್ಟಾಯ್ತ್ರಿ? 44 ಆಯ್ತು. 44 ದಾಗ ಮೈನಸ್ 1 11 ತೆಗಿಬೇಕು, ಎಷ್ಟಾಗುತ್ತೆ ನೋಡಿ? 14 plus 22 is equal to 6, right, minus right 25, correct, 25 divided 14.74 is equal to 20.17 into 10 raised to 25 Newton, 10 raised to 25 Newton force between those two masses. ಅಷ್ಟು ಮಾಸ್ ಏನಿದೆ ಅಂತಂದ್ರೆ ರೈಟ್. Next one. Sphere of mass 20 kg is sphere of mass 20 kg. Sphere of mass 20 kg is attached by another sphere is attached by another sphere of mass 10 kg of mass 10 kg of mass 10 kg when their centers are 20 centimeter apart. When their centers are 20 centimeter apart. When their centers are 20 centimeter apart with a force 3.3 into 10 raised to minus 7. 3.3 into 10 raised to minus 7 Newton. Right. So calculate the constant of gravitation. Calculate the constant of gravitation. Here, so the solution becomes here what? Two masses are there. M1 is how much? 20 kg. M2 is how much? 10 kg. Right. So they are how much? 20 centimeter apart. Radius or distance 20 centimeter. So 20 into 10 raised to minus 2. Right. So there is force is also given how much? 3.3 into 10 raised to minus 7 Newton. Right. So then now we are going to find out what the constant of gravitation. Constant of what? Gravitation. So here formula is like this: m1 m2 divided by what? R square. Right. So now I am going to take G is equal to f r square divided by m1. F r square divided by m1. Right. Once again here G is equal to what is our force given here? 3.3 into 10 raised to minus 7. 10 raised to minus 7. Right. So then R is 20 into 20 into 10 raised to minus 2 into 10 raised to minus 2. 2 times r square is there, right? So m1 how much? 20 into 10, right? So this 20 cancel, this 0 cancel, right? So then g is equal to see what is there? 3.3 into, so this is minus 2, this is minus 2, minus 4, minus 7, 10 raised to minus 11, 10 raised to minus 11, right? So now it becomes, see, 3.3 and another 2 1 is there, so divided by 2, right? Divided by, so no 2, right? Already 2 1 will cancel there. So then g is equal to 2 3s are 6, 2 3s are 6 into 10 raised to minus Newton meter square per kg square. Newton meter square per kg square. So this is the what?